Okay, I'm doing a problem on collisions. The problem states Puck 1 sliding along the x-axis strikes stationary Puck 2 of the same mass. After the elastic collision, Puck 1 moves off at a speed of v1f in the direction of 60 degrees above the x-axis. Puck 2 moves off at a speed of v2f in the direction of 30 degrees below the x-axis. The problem wants me to find the v2f in terms of v1f. So first we start off by drawing the picture. Puck 2 is stationary at this point, but Puck 1 is moving in the x direction, and that makes it one-dimensional. But what makes the problem as a whole two-dimensional is when Puck 1 hits Puck 2, and as a result, they both move in a y direction. Puck 1 moves in a 60-degree angle above the x-axis, and Puck 2 moves in a 30-degree angle below the x-axis. And the pucks are the same size, same mass, so the mass of Puck 1 equals the mass of Puck 2. To begin our problem, we use the momentum conservation theory, which would allow us to use this equation, which would mean the final momentum for 1 plus the final momentum for 2 equals the initial momentum for 1 plus the initial momentum for 2. So we break those down into components. We do x and y variables. We use the x and y variables because it's a two-dimensional problem. If it was just a one-dimensional problem and it was just going in the x direction, we would only have to break it down into x components. But since we're going in both the x and y directions, we use we find this for x and we use that for y. Okay, starting off, since Puck 2 would be stationary, the initial momentum for x would be 0. But we know everything else except the initial momentum for Puck 1. But we're just finding, the problem wants us to find the final velocity for Puck 2. So we can either use the y components or the x components to do that. But since we don't know this, we can't find it. So we go on to the y components. Now initially the two pucks were only going in the x direction. So all the y variables, the initial y variables would be 0. So that's why we cancel those out, leaving us with just the final momentums from each puck. So that leaves us with mass 1 times velocity 1 final y plus mass 2 velocity 2 final y. Okay, for Puck 1 it was going in 60-degree angle, so that's why we use 60 as the theta. And in the y direction, you see that the theta is opposite to the y, so that's why we use sine. Okay, and we do the same thing on the other side, because it would still be, the y direction would be opposite to the theta, but we use the 30-degree angle because this is for Puck 2. We cancel out the masses from each side because the masses are equal, and we divide by sine 30 on each side because we're looking to get the v2f alone. When we leave the v2f by itself, it gives us v1f sine 60 divided by sine 30, and that leaves us with 1.73 v1f. And that's our final answer, because the question wanted us to find v2f in the terms of v1f.